Welcome to Optimizing Spring Data Couchbase. My name's Davis Chapman. I am part of the Couchbase Professional Services organization. This presentation is to go over ways of optimizing the performance of your Spring Data applications. So we're going to briefly hit on three areas. One is why Spring Data. Two is some of the optimizations, just a couple of optimizations for your data modeling. And the bulk of our time will be spent on how to optimize the queries that are generated from Spring Data. So why Spring Data? Spring Data kind of falls into a category of technologies called object relational mappers. This is a technology that came out of the relational world, the object-oriented programming and relational world, for mapping normalized relational data to data objects that the developers are used to working with. So the first question is, why would you want to use this with a database like Couchbase? Because you usually store your data in Couchbase in a JSON document format, which directly maps to your POJOs. They can easily serialize and deserialize back and forth. So there is nothing to map between relational data and your data objects in your application. Second, ORMs have performance overhead. They're going to slow down your database interaction just by the nature of it. Any genericized functionality is going to be less optimal than specialized functionality. And let's be honest, this is something that drives a lot of my associates, myself included, in our professional services team nuts, because one of our goals is to optimize your database interaction from your application, and we want to get the utmost performance out of there. But because the ORM has some performance overhead, we're already being handicapped there. So there's only so much we're going to be able to do to optimize that. So why use Spring Data since we're taking a performance hit by doing that? First thing is, it's easier to find Spring Data programmers than it is to find Couchbase programmers. There's a lot more Java programmers out there in the market that have experience with working with Spring Data than there are with working with the Couchbase SDK. Second, it is a simplification of the Couchbase SDK. So it's much easier to learn and get started if a programmer isn't experienced with Spring Data. Third, it generates a lot of code. So there is a lot less code to write. So the real reason for using Spring Data is to optimize your developers and your development side of things, generating the code, writing the code, as opposed to your application performance. But there's still things we can do to optimize that performance, and we want to do, because your applications still have SLAs they have to meet. They have to perform reasonably well. So we're going to look at three things in the data model optimization. The first is, by default, Spring Data is not Couchbase mobile compatible. If your use case has a mobile aspect of it, you can't use Spring Data right out of the chute. If it doesn't have your use case doesn't have a mobile aspect yet, but may in the future, this is also a concern. Why is this? It's because Spring Data automatically adds an additional property to your JSON documents, and this is the _class property. This property performs a couple of duties. One, it kind of functions as your doc type property. So what is your document type for your JSON objects? Second, it is used by Spring Data for knowing what data class to instantiate in your Java application for serializing and deserializing the JSON document into your POJOs. And why is this a problem with Couchbase Mobile? It's because Sync Gateway doesn't allow property names prefixed with an _ character. So what can you do about it? Actually, there is something you can do about this. There is in the configuration for Spring Data, Couchbase, there is a type key property that defaults to the underscore class setting. But you can override this with returning the type key sync gateway compatible setting, and it converts it from the underscore class name to Java class. Now your application can be used with Couchbase Mobile. It's now Couchbase Mobile saved. So this is, if you have a mobile aspect, if there's any chance there may be a mobile aspect to your use case in the future, anytime, go ahead and use this. I have no reason why I would not be using this in any of my use cases. Second is I think it's a good idea to enable your CAS locking operations. So you do this by adding the @version proper annotation to one of your properties in your data objects. This enables all your CAS locking operations so that you get the exception thrown if the CAS is no longer valid because someone else has updated that document before you did. So you know if you try to force that in there, you're going to overwrite someone else's updates. And so you can refresh and do everything you would with a CAS mismatch exception. The third aspect about your data modeling is your field names can be problematic. Developers have a tendency to like to use very descriptive property names, and some of these can be very long. And the problem with this is these become very descriptive JSON property names. So if you've got every instance of this document in your Couchbase database will have this same property name in the document itself. If you got a half dozen, it's not really that big a deal. Yeah, it's a little extra overhead. But if you got 100,000, a million, 10 million of this document type, that adds up to a lot of unnecessary storage space, both in your Couchbase database and in your payloads going across the wire. Luckily, using the @field annotation, you can provide a shorter name to use. So this way you're able to have your very descriptive property name in your POJO, in your application. But in your JSON document, you're going to have a much shorter name. And this will save, in this case, we're saving about 30 characters per document. And imagine that you have I've seen very many clients that have at least a half dozen, maybe a dozen different properties in a single document type with long names like this. This allows you to have much shorter names, saving a lot of storage per document, smaller payloads, and saving a lot of storage space in the Couchbase database. So that's it for document optimization. Now we're going to go with query optimization. Spring Data, one of the benefits of it is it will generate queries for you from just descriptive method names that you create in your repository interface. Because of this, because it's generating these queries, one of the requirements in the Spring Data documentation is it wants a primary index on the bucket that you're running Spring Data against. This is due to Spring Data has no knowledge beforehand of what indexes you might need. Yes, you can do the @index annotation in your data elements if you've got permissions to create indexes, and it will generate some of those, but they still may not be the optimal indexes for the queries that are being generated. Having a primary index will allow it to run any query that it generates the syntax for, and it will not error out in terms of invalid query index syntax. So the challenge here is a primary index is not going to perform well. Primary index is only indexing the document IDs, so any query you send to Couchbase that's using a primary index is going to fetch every single document in that bucket to evaluate against your where clause in the generated query. In a development cluster, you probably got a few hundred, maybe a few thousand documents. You're not really going to see a significant performance hit by doing this. In a production cluster where you got millions of documents, tens of millions of documents, this is going to be a significant performance hit. You do not want this. It should be avoided at all costs. And in fact, this is why we recommend not having a primary index in anything other than a development cluster. We don't want them in your QA cluster because that's where you're going to catch any queries that don't have a supporting secondary index and are still dependent on a primary index. And all the way up to your production cluster where you don't want the chance of any query running against a primary index. So the challenge here is how to find that generated query. In previous versions of Spring Data Couchbase, you could have just set your the query object in the library, Spring library, to debug mode in your logging level, and the queries would have been showing up in your application log. Unfortunately, in the 4.x version of Spring Data Couchbase, this functionality is no longer there, at least not yet. There's an issue out there for it. It may be there soon, but it's not there yet. So what do we do in the meantime? The meantime, what we have to do is use the completed request namespace. So by default, the completed request namespace is going to have any queries that take more than a second to run. This may not record all of your queries that you're doing in a small development cluster. So what we want to do is set that threshold much lower. So you get there by going to, in the Couchbase Management Console, you go to your settings on the left side. On the right side, expand your query settings area and scroll down to the completed threshold and set it low. In this case, we're setting it to 10 milliseconds. So this will record in the completed request namespace any query that takes more than 10 milliseconds. You may have to set it even lower than this, depending on what queries you're trying to capture in there. You can set it as low as 0. That will record every single query in there, even those that are perfectly fine, have a good index, and don't need any further examination. So the next problem is how to find the queries that were generated from your Spring Data Couchbase application. You want to run this exact query in the query workbench to find these. Select distinct raw statement from system completed requests where user agent like Couchbase.-java %. After the percent, it will vary from here with the version number of the SDK that you're using, but the Java SDK is always going to start with Couchbase.-java. You also want to filter on your users. This should be the user account that your Spring Data application is connecting to your Couchbase cluster using. And this will give you a list of queries that have been run from the Java SDK with this user ID. And you can see below we've got our query that was generated from the method in the repository, which we can see has a problem right here because it's using the property name from the POJO and not the shorter name that we used in the annotation, the field annotation. So we can't use the field annotation name in the repository interface because then you'll have a compile time error that says it can't find that property in your data object. So you have to use the names in your data object for it to generate this. There's ways around this. We'll get to those shortly. So know that this is an issue. So let's switch to a different query in our repository, where we don't have to worry about field name translation. So here's one where we're doing in our good guy repository, find by nemesis, and it's creating our generated query where it's select ID, CAS, and asterisk from the bucket. So it's got the Java class and our field in there. So we take that and pop that into the query editor, take out the backslashes around the quotes, and do an explain plan on there. And we can see that this is using the primary index. It's doing the primary scan over there on the right side. So we know we need to create an index for this. So we can create an index on Nemesis field where the Java class is our class here. And we explain the query, and we've got an index scan now using the index we just created. So this is okay. This is reasonably well for if it's not fetching too many documents. We can also add a query hint over the method in order to have more control over the generated query. And there are shortcuts available to you. The pound nickel select entity will generate your select and from portions of your query. Your pound nickel filter will add the Java class or underscore class portion of your query for finding the right documents. And this basically looks the same as the generated query that we had before. So let's see if we can improve this. If we specify the select with the pound nickel fields and the pound nickel bucket for the bucket, we get a little bit better query in the fact that we've got the ID and the CAS value, but we no longer have the star where it's selecting the entire document. So no wildcard in the select thing. We pop this over into the query workbench and do an explain plan on it. It looks basically the same. We're still doing the fetch of all the documents, primarily because that CAS value is in there. So we can revise the query and be explicit in there and return 0 as the CAS value. And we see in the generated query that's coming across fine. And in our query plan, we no longer have a fetch phase. So if this is returning 1 million documents, it's not fetching 1 million documents from the data service. This is basically a covered query at this point. So it should perform pretty well. The problem is with this query is now we've got just the ID, so we actually have to perform the fetch ourselves from the data service. So what have we accomplished? We really just moved the fetch from within the query to our code. Well, maybe we can do a little more efficient fetch here. Maybe not. So it's still just moving the part of the problem. So the question is, can we convert this to a covered query? So we'll build a more detailed query where we're specifying the data elements that we need from the document here. So we want the CAS value, we want the first name, last name, the health, and the nemesis from the document, and leave the from and the where as is. We create a new index, so we're including all those data elements from the document in the index. Nemesis, first name, last name, health, and include the CAS value, meta.cas, in there. We see from the generated query that it should be using that. And we check our query plan, and lo and behold, we've got a covered query now. So this allows us to run the query in our code and not have to fetch any documents. So we've eliminated the fetch from both the query and our code. And if this is returning half dozen documents, the fetch isn't that big a deal. If this is returning thousands, tens of thousands, hundreds of thousands of documents, 1 million documents, that fetch makes a big difference in performance. And we can see from the result sets that we are getting the CAS value. So the CAS value is in the index. So what happens when you got a very large data set that you need to do paging on? How can we use this here? Spring Data does make paging large data sets very easy with the paging and sorting repository. You just extend that with your interface for your repository, and you have it automatically adds limit and offset to your generated queries. The problem with this is that as your offset grows, you will have increasingly slower response from Couchbase, from the query service, because it has to build the result set and then move through the result set to find where that offset position is before starting to return the data. So is there something else we can do instead of that? Yes, we can do Keyset Pagination. Keyset Pagination will provide that same paging functionality with consistent response times. How this works is you're indexing and sorting on a unique property, and you're conditioning each page where the sort property is greater than the last value on this property was retrieved. So what would this look like in practice? You'd have a query something like this, where you're selecting your med ID, your CAS, your properties, including a GGID, which is a unique value. And in your where clause, you have where GGID is greater than the last one you passed in, and you're sorting on that with passing in a limit. So you're still passing in a limit for how many you want, but you're no longer passing in an offset. So for find all, you'd build an index where the first field is the field that you're sorting on. By default, Couchbase indexes are sorted in ascending order. So as long as you're wanting these returned in ascending order, you're fine. You can also specify in your index definition to sort it in descending order if that's the order that you want them returned in your query. So at this point, you're able to code your paging logic where you're getting them all, and then you're just iterating through your result set just to get the last GGID value from each page before you get your next set. You're also doing whatever you need to do in that iteration with the documents returned. When you're querying on a specific value or a set of values, you want to move the field that you're sorting and paging by in your index to just after the fields that you're filtering on. So in here, we're basically taking the Keyset Pagination thing. We're filtering on Nemesis, so we're having Nemesis and GGID. So in our index, we have Nemesis first and GGID second. And that allows us to still paging on GGID, we're filtering by Nemesis. The challenge is this, if you just have both of these indexes in here, this query is as likely to use the other index as it is this one. So that's a challenge for limiting how many indexes you have. And your code basically looks the same. Finally, before I'm running out of time here, the last thing I wanted to touch on is I'd be remiss if I didn't mention using the Reactor framework. With Couchbase SDK 2.7 to 3.x switch, we switched from RX Java to Reactor framework, and the Reactor framework is very compatible with the reactive Spring framework. So this allows you to write asynchronous code, and it makes more efficient use of the client CPU and other resources. And that's it. As I'm running out of time, here's my contact information, and I'd like to thank you very much for your attending this presentation.